In this video, we are going to talk about how to obtain or form a differential equation. Okay, it says obtaining or forming differential equations. Now, we are going to do that no other way other than using examples. It is the best way for you guys to understand whatever is being talked about in forming or creating a differential equations. Now, in this case, we are having 4 examples. Okay, in our first video, we're having 10 examples on differential equations. We're having 4 examples here, and these are not differential equations, rather. They are solutions to a differential equation. Remember I said in the beginning of our previous video that differential equation simply means, or rather, a differential equation is an equation that we what differentiated and rearranged, okay, into an equation. Okay, so in this case, we're having the solution after solving that differential equation. Okay, and this solution, with this solution, we want to get the possible differential equation, okay, or a form that is good to take. Now, to do that, we are going to take note of some key features. What are those key features? Do take note that whenever we are giving a solution to a differential equation, or a general solution, in this case it is written general solution, this will be talked about more in another video again. Okay, so we are talking about the solutions given here and we want to get the differential equations. Now, the key feature you must take note of is that depending on the number of constants that is given, that is what is going to determine how many times we will differentiate. Now, check. For this number 1, we are having just one constant. Obviously, we are going to take a as a constant, not x other. We are not differentiating y with respect to a, except stated otherwise. Stated the equation that you have to differentiate y with respect to a. But if they did not say anything like that, you are just giving the equation. Take note that you are differentiating y with respect to x. And these alphabets are usually the constant. We make use of x and y most times in differential equations. Okay, so you are differentiating y with respect to a with respect to x other. A is a constant, so we have just one constant here. That means to form the differential equation, we are going to what now? Differentiate once. Okay, so for number 2, we're having 2 constants, c1 and c2, so we are differentiating what now? Twice. For number 3, just one what now? Constant. For number 4, 2 constants, so also what now? Differentiating twice. Okay, now let me walk you through the steps on how to form the differential equations for these what now? Examples. Okay, so now take note, what are the key features? So take note of the key features. Okay, first key feature, you should take note that the number of constants, okay, in the solution determines the number of times we are to differentiate. Okay, the number of constants in the solution determines the number of times we have to differentiate. That's one thing you must take note of. Okay, so in this case, I've explained already the number of constants differentiating once, twice. Okay, now the next key feature we are going to take note of is that after differentiating, okay, after differentiating, comma, we make substitutions to eliminate all constants. Okay, so while creating a differential equation from the solution, after differentiating, we try to make substitution, that is substitute one equation into another one, okay, to make sure all these constants are being removed. Okay, that is the trick. Okay, we make sure all the constants are being removed. Okay, for cases like this, most times you'll be given what we call conditions. Okay, you'll be given conditions to find a particular solution. Okay, that's what happens. You'll be given conditions to find particular solution. Hence, there are 2 solutions to a differential equation: general solution and then a particular solution. This will be talked about in a different video, okay? Explained in detail. Now, these are the key features. Let's now work with example 1. So for example 1, we are given y is equal to 2ax, okay? So we are given y is equal to 2 x. Take note, dy over dx is same as y prime. So if I'm writing y prime of dy over dx, don't be confused if you see a different thing in a different example. Okay, it is what now? The same thing. I'm telling you the same thing, just that y prime is the shorter way of writing it. Okay, so now since we are having just a single constant, how many times are we differentiating? Once. So differentiate y with respect to x, we get what now? Y prime, and this is equal to differentiate 2ax. What do you get? You get what now? 2a, right? Next thing, what step 2? Step 2 simply means after differentiating, we make substitutions. That is, we want to substitute these guys into this one, okay? Just so that we can remove a or 2, as the case may be. Okay, so from the question, we notice we are having y is equal to 2a times x. Now this can be written as y is equal to 2a times x, right? And then we notice that 2a is what now? Y prime. Okay, 2a is y prime, so we can substitute. Then it gives us y is equal to y prime times x. Now this is our what now? General solution. Okay, so this is the general solution to the differential equation. If more is required of you, okay, for cases like this, most times you be given conditions, like I said, okay, to find the particular solution. And then for number 2, we're having y is equal to c1x plus c2x squared. Okay, so for number 2, we're having y is equal to c1x plus c2x squared. Now this one is quite different because we're having two constants, right? So for the two constants, it means we're differentiating how many times? We're differentiating what now? Twice. So I'm going to call this equation 1 because I know I'm going to be substituting. So I'll call that equation 1. Okay, now when I differentiate this guy, I'll get y prime is equal to differentiate c1x to get c1, okay, plus when you differentiate c2x squared, you get 2c2x. Let's call this equation 2. And then for equation 3, differentiate again. Remember, we have to differentiate twice. So when you differentiate this again, we're differentiating this again, not the question. So when you do that, you get y double prime equals, when you differentiate c1, you get 0. Differentiate 2c2x, you get what now? 2c2. So this is what now? Equation what now? 3. Now, like I said, after differentiating, we make substitutions to eliminate all constants. The constants here are c1 and c2 in the 3 equations. So make substitutions to what now? Eliminate these two guys. Okay. Now, how can we do that? Now, when you look at this equation 1, I can choose to divide through by x. Okay, divide through by x. Now, when I divide through by x, I'll notice I'll have c1 standing alone, just like this one, and then I'll have c2x, just like c2x. That is the reason I'm dividing. Note that for every question you arrive at a problem like this, you divide by x. You just have to practice more examples and see which one works depending on the problem you are given. Okay, so for number 1, I'm going to divide through by x. When I do that, okay, let me write it. Divide equation 1 by x. I'll have y over x equals c1 plus c2x. Like I said, the only reason I'm doing that is because I want it to be similar to equation 2 so I can subtract. It's like solving simultaneous equation. Okay, so after getting this, I'll call this equation 4. Now the next thing I'm going to do, I want to subtract equation 1 from equation 2 or 2 from 4. Okay, so subtract equation 1 from equation 4. Okay, now equation 4 is this guy, y over x. So you have y over x minus what is equation 1? Equation 1 is y. Okay, and that is equal to what is equation 4? c1 plus c2x. So we have c1 plus c2x minus what is equation 1? c1x. I think what I should be doing is subtracting equation 2 rather from equation 4. Okay, equation 2 from equation 4. That's what I want to do because these are the two equations that are similar, not one another. So subtracting equation 2 from equation 4, I have y over y prime, y over x rather minus y prime, okay, equals c1 plus c2x, which is this guy, okay, minus what is y prime? c1 plus c2x plus 2c2x, okay. So we have c1 plus 2c2x. That's what we're going to have, okay. Proceeding from here, we're going to have y over x minus y prime is equal to c1 minus c1, that's 0, okay. c2x minus 2c2x, that'll give you minus c2x, right? Okay, that's what you get. Now, after doing that, we are still having c2 in that case. Okay, we still want to eliminate it completely. We notice that we're having y double prime is equal to 2c2. We can make use of some substitutions from this equation 3. So from equation 3, we notice that y double prime is equal to 2c2, of which we notice that 2c2 will then become y double prime over 2. Now let's substitute into that equation. So we're going to get y over x minus y prime is equal to minus open bracket c2 is y double prime over 2 times x. Okay, we can put the bracket to get y over x minus y prime equals minus y double prime x over 2. Now, we want to rearrange the equation because we've succeeded in removing c1 and c2. Okay, now multiply both sides by 2x because 2x is the LCM. Okay, multiply both sides by 2x so we can clear the denominator. So now multiply both sides by 2x. Okay, multiply through by 2x. 2x times y over x, that will give you 2y. Okay, minus 2x times y prime, that will give you 2x times y prime. Okay, 2x times this guy, 2 cancels 2, so we're having x, we have equal to minus x y double prime. Okay, we can rearrange this, bring this guy to this side, so we have x y double prime minus 2x y plus 2y equals 0. So this is the general solution. Okay, I'm going to call this the what now, the general solution. So this is the general solution to the differential equation. So what I'm trying to say is that when you solve a differential equation like this, what you should get is what now, a solution like this, which is y is equal to c1x plus c2 what now, x squared. This is what now, general solution. Okay, and then going to number 3, we are having y is equal to c exponential minus x. This one is similar to number 1 because we are differentiating once. So y is equal to c exponential minus x. Okay, now to do this, we are going to differentiate once. So we're having y prime is equal to minus c exponential minus x. Okay, now you notice that c exponential minus x is what now, y. So we have y is equal y prime is equal to what now, minus y. Okay, so we can as well say that y prime plus y is equal to 0 is what, the solution, or rather the general solution to the differential equation. Okay, we've been making an error ever since. We've been making errors. Now the errors we'll be making is that we're giving general solutions. Okay, we are not forming the general solution, rather we're forming the differential equation. That's a mistake, so that's just what you should clear. Okay, that's just what you should clear. So we are having the differential equation. This is the differential equation, not general solution. Okay, that's just a useless mistake. I don't know how that happened. Okay, for number 2, we're having the differential equation, and then we're having the differential equation. Okay, so these are the differential equations from the general solution. Okay, these are general solutions, and the differential, this is like the question and the answer, or the question and the answer. Okay, when we solve this, we get this. When we want to bring it back, we do this to what now, we get that. Okay, so those are the what now, the solutions, and like this should be number 3. Okay, now over to the last question, question 4. We're having y equals a exponential 2x plus b exponential minus x. Okay, so now let's attempt this problem. This key feature should have been noted on the record book by now, so I'm going to take it off. Okay, so for number 4, we are given y is equal to a exponential 2x plus b exponential minus x. Okay, we're having two unknowns, or two constants rather. Okay, two constants. So I'm going to call this equation 1 because I'm seeing two constants and now I'm differentiating twice. So when I differentiate first time, I get y prime is equal to 2a exponential 2x. Okay, when I differentiate b exponential minus x, I get minus b exponential minus x. I'll call this equation 2. And then for the third one, differentiating again, I will get 4a exponential 2x okay, plus b exponential minus x equation 3. Now, looking at this problem, next thing I want to try and do is try making use of substitutions. Okay, I think substitution will always work, but sometimes it's just too complex. But then there is another method that really works. Okay, it works when we're having similar equations. Okay, most times it works when we're having trig functions and exponentials because they are similar. But then when we're having just algebraic functions, it doesn't work most times because the x tends to disappear as we go on. Like this one, on the first time, we had just what now? Only x. Second time, the x was gone, so we can't really apply the method I'm going to do here. Okay, but for this one, since we are still having the expansions or the expressions rather, exponential, okay, we can still what now work it out through. Now, this is called the matrix method. Okay, so we are saying for this equation to be true or consistent, the determinant of the whole equation has to be what now? 0. So I'm taking y to this side, taking y to this side, and everything becomes equal to 0. So when I take y to this side, I get what now? Minus y. Okay, so I'll get minus y. Okay, next thing I'm going to do, I'm going to what now? Skip out the constant because it is the constant I want to remove. We are done differentiating. It is the constant I want to eliminate from step 2. Okay, so I'm going to have exponential 2x, and for this one, we have exponential what now? Minus x. So for this one, take y prime to this side, we have minus y prime, okay, 2 exponential 2x, okay, and then we have minus exponential minus x. We are just removing the constant, which is a, not the numbers. Okay, so having minus y double prime again, 4 exponential 2x, and then exponential minus x. Okay, so we're saying the determinant should be equal to 0. Okay, now we can as well apply the properties of determinant. This will make it easier for us to solve this problem. Okay, applying the properties of determinant. So once we have anything that is constant, okay, on any row or column, we can as well factorize it out. So for this one, minus 1 is constant. So we're going to have minus 1 into brackets. Minus 1 is constant. We'll factorize it out. For this one, exponential 2x is constant. We have exponential 2x times exponential minus x is also constant. Exponential minus x. Okay. So what are we left with? If we remove minus, we get y prime, y double prime, and then when we move exponential 2x, you get 1, 2, and 4, and then for this one you get 1, minus 1, and then 1. So 1, the determinant will be equal to 0. Okay, we can choose when we divide both sides by everything here, this one disappears, so we're left with just this determinant equals to 0. So next thing, solve the determinant. To solve the determinants, we make use of the determinant formula. For 3 by 3, we have y open bracket, okay, 2 times 1, that's 2, minus 4 times minus 1, that's minus 4, so this gives us a plus 4, okay, minus 1 into bracket, y prime times 1, so we have y prime minus y double prime minus 1, so we have plus y double prime, okay, plus 1 in brackets, y prime times 4, so we have 4y prime minus 2y double prime. Okay, next thing, and this is equal to 0. Next thing, you want to simplify this guy and get your answer. So we have 6y minus y prime minus y double prime, okay, plus 4y prime minus 2y double prime equals 0. Okay, I just hope there is no mistake. To be sure that there is no mistake, I want us to go over it again. So we have y, and I have 2 times 1, that's 2, minus 4 times minus 1, that will give you plus 4 because there's a 2 minus. And then we have minus 1 open bracket, y prime times 1, y prime, y double prime times minus 1, that's minus y double prime plus the natural minus, we get a plus here, and we have plus 1 into brackets, 4 times y prime, we have it here, minus y prime. Okay, I think that's cool. So have this, and then we'll expand. What do we have left? Let me bring it up. So when I bring it up, what am I going to get? I'm going to be left with 6y minus y prime plus 4y prime. What do I get? I'll get plus 3y prime, right? So these ones are out, these ones are out, these ones are out. So I'm left with minus y double prime minus 2y double prime. They have minus 3y double prime equals 0. Okay, when I divide through by 2, I should get when I divide through by 3 rather, I should get 2y plus y prime minus y double prime equals 0. Okay, this could be rearranged to equal y double prime minus y prime minus 2y equals 0, and this is the differential equation. So when we solve that differential equation, our solution should be given as this question 4. That's what it is saying. Okay, you just have to make sure there are no errors there. Okay, in the calculations, make sure they are error free. Okay, and then we'll arrive at the answer, which is the differential equation. Okay, I think that's valid. If I found that is if there are no mistakes in this calculation, because I'm just suspecting that there are probably 1 or 2 errors there, but you can check for yourself. Okay, if there are errors, you can as well correct it, but if there are none, then you are good to go. Okay, so we just have 4 examples that I've explained, differential equations. Okay, in our next video we'll talk about the difference between a general solution and a particular solution alongside examples. Okay, so do well to click your notification bell so that when that video or more videos are being uploaded, you get notified. As well, smash the subscribe button, leave a like, and then put a comment in the comment section if you have any questions to ask, or you have a video you want us to talk about, okay, on this section or any other topic that is important to you in the aspect of studying mathematics. So see you in the next video. My name is Dr. Flash. God bless.